So welcome everyone. I'm Sri Krishnan. I'll be presenting our paper Redactable Blockchain in the Permissionless setting. All right, so let me jump directly into blockchains in a minute. So you may know blockchain is a infrastructure where users can upload data, and it's maintained in a distributed manner. And the properties of a blockchain ensure that the data that's uploaded has some sense of public verifiability and immutability in the sense that it cannot be modified or edited or removed in a later time. All right. So what kind of data can this be? It can range from a normal payment from a user to another user, or multimedia files, or complicated contracts, as we saw before, as we saw in the previous talk. So it can range from these, and it can also be quite arbitrary and objectionable content that can be inserted, which can make the data that gets inserted into the block to be sometimes harmful. All right. So why is this a problem? Let's take the case where some jurisdictions around the world are fined for full nodes for running a blockchain that has some harmful data in it, while some others are clearly not, and this could mean bad for the full nodes that are there in the jurisdiction. I mean, it harms the adaptability of the blockchain itself. And for law enforcement agencies, this clearly is a problem. The immutability of harmful content that gets into the blockchain is clearly a problem, and it's been discussed for quite some time now. All right, so here's where we propose our solution. Ours is a redactable blockchain where we do not make any additional trust assumptions. And we redact content after a certain number of miners agree on what needs to be redacted. It's publicly verifiable and accountable. And it's agnostic to what kind of underlying consensus mechanism you use. If it's proof of work, proof of stake, we don't mind. And we do not make use of any heavy cryptographic machinery, so this is quite practical. And later in the talk, I will show you how this can be integrated into a system like Bitcoin currently. All right? So why don't simple solutions, straightforward solutions, why don't they work? Well, if you have the data that inserted in one of the recent blocks in the chain, it's always possible to create an alternate history and kind of fork away the harmful content, and such that no one needs to store a broadcast or anything. All right. But what if the data is deeply embedded in the chain, and to do a fork, it's almost like doing a hard fork, and it can be quite a lot of hard work on part of the miners to do this. All right. What if miners in the network decide to locally drop the data? Just they have some informal discussions and they just drop the data. Well, what happens because of this is that the verifying the hash links on the blocks where the data is dropped becomes a problem now, because you don't have the complete data to verify the block and the link to the next block and so on. Well, these miners could very well say that, okay, we know where the data was dropped, we know what was dropped, so probably we can help new users who join the network. We can clearly tell them what's happening. Well, let's consider a scenario. A new user joins the network, and he asks for a version of the chain. And a honest user would do this, would give the redacted chain, which was locally dropped, all right, and explain why the links there cannot be verified. Well, if there's an adversary, he could arbitrarily choose a block in the middle and drop a data and say that, oh, this was the one that we agreed on. And if you think about it, a new user could potentially have many, many more versions where he cannot make out, he cannot verify the links, so he cannot make out which is the correct agreed upon chain anymore, right? Well, how could you get over this? What if you have a trusted authority in place, and your new user takes this chain that he received from someone, takes it to the trusted authority, and he says like, is this the correct one? And probably the authority says, yeah, this is the one. They decided to drop it here, and you can accept this. All right. I mean, of course, the new user trusts the authority, and he takes this chain as the current version. So solutions that are similar in spirit were proposed by Atheniese and EuroSNP in 2017 and Derler et al. In NDSS this year. So they involve a trusted set of committee. It's a permission setting, and it involves some large-scale MPC across all the miners, and they make use of what is a chameleon hash to kind of repair the the broken links so that it's verifiable now. All right. Well, what are the key challenges for a permissionless setting like Bitcoin? Right? There are no trusted committee here. It's a free peer-to-peer network, right? And how do people in the network agree on what's dropped and what's not dropped, what's harmful, what's not harmful? So you need to have an agreement or a consensus on this. And it needs to be publicly verifiable and accountable as to what, where, and when some harmful data was dropped. And of course, it needs to be practical. A large-scale MPC could prove prohibitive in this manner. And there are no solutions known yet for a permissionless setting like Bitcoin, right? And here is our protocol that we aim to achieve. We aim to solve all those challenges in a simple and an easy to understandable way. All right. So let me describe our protocol now. We first need a little bit of formalism. So we call what is a redact policy. The miners in the network need to agree on this policy that basically says under what condition and under what level of agreement does can a data be redacted. So for example, it could be 51% of the miners need to agree on a redact request, and that particular data can be redacted. All right, so what about the properties? Our protocol does not affect chain growth because we do not remove blocks, and so we do not affect the growth of the chain over time. Chain quality is preserved with respect to the policy as long as the number of votes required for a redaction is more than the adversarial bound on the network. All right. And of course, we do not have common prefix because we are going back in time and changing stuff, but we do have what is called an editable common prefix, which needs to comply with the policy of the network. So if a policy approves a particular redaction, then honest players in the network are guaranteed to have the same prefix. All right, so how does our protocol work? So this is the blockchain that we have currently. So we need to modify the block header structure in a way that instead of one link, now you have two links between blocks. All right, so for ease of convenience, we call the first one to be an old link and the second one to be a new link. All right, and how do you request for a redaction? Any user in the network can ask for a particular data to be redacted, so he needs to make this request. So he does this by first constructing what is called a candidate block, which he wants it to replace the original block, and he publishes the hash of this block onto the chain and sends this candidate block into what is called this candidate pool of candidate blocks. All right. So now miners can deliberate on the candidate block, so they retrieve this from the pool, and they can decide to vote for this candidate block or not, right? So how do they do this vote? They remember that the hash of the candidate block is on the chain, so the miners have access to this. So they take this hash, and if they decide to vote or not vote, they include it into the mined block. So here the green user obviously does not want to vote, so he mines the block without the vote for the candidate block. But some other users may want to, so they include the hash of the candidate block into their newly mined block. So this goes on, all right? So once the voting phase is